In this tutorial, I will go over subdividing geometry, applying particles to this effect, using the Vex language, and a brief look at Houdini's take system. To start off, let's drop a geometry node. So if you press tab, you get the menu, and if you type in the search geo, you get geometry, press enter, and drop it down. Now we want to go into it by double clicking, press tab, and we want to drop a platonic solid. Now here you can select the solid type, so you get different shapes. I'll go with this one. And now we want to drop a poly extrude. Now we want to connect them together. Select the poly extrude display / render flag. Click that, go back up, and what we want to set the divider into is individual elements. The distance, this is what we're going to be editing, so let's go to 24, distance, right click, keyframe, set keyframe, then proceed to 48, change the distance to 0.2, right click, keyframe, commit change. Now as you can see, the faces are extruding. Now if this was set to connected components, the whole shape will expand, and this is not what we want. So let's go back to 24, individual elements, and now let's go to spine control, scroll down to thickness, and we want to change the thickness ramp. If this isn't expanded, you just want to click this little arrow, make sure the end one is selected, and let's set a keyframe at 24, so set keyframe, and this will be 1. Go to frame 48, and we want to change this value to 0.5, right click, keyframe, commit change. As we can see, get this effect. Now in order to further this effect, it's rather simple. We just want to copy the poly extrude, and via Control C, then Control V to duplicate it. Now it's still connected to the platonic, so we want to select the line and delete it. Now let's connect poly extrude 1 to poly extrude 2. Now as you can see, both values are in the same frame range, which is not what we want. So let's go to 48. Go back to distance. So we want to change it up a bit, so let's change it to 0.1. And in order to change the frame range, we want to go to Windows, Animation Editor, where you can open with Alt-Shift-F. Now this is up, we want to select the whole animation timeline, or we can do that via Control-A. Now you want to go to the start of the first one we set, left click and drag it. So let's drag it over one set to 48. Now let's close that and see what it gives us. So the start shape, the first set, and then the second set. Now let's do this one more time to finish this effect. So Control C, Control V, get rid of the line, connect that one to that one. And as you can see, this will be in the set of 48 to 72. While this effect is also nice, we want to change it. So back to Window, Animation Editor, make sure the poly extrude 3 node selected, because if you select the second one, you go back to where it is. So let's select poly extrude 3, Control A, and drag it over one set to 72, and N will be 96. So from the start, you can see the effect going. Now it goes a bit quick, but if you change it to, where is it? Windows, global animation options, real-time playback, close that, and it will play in real time, so 24 frames per second. So now the effect's done, we just want to actually add a normal to the end of it. Yep, connect it, and then we can move on to creating the particle effect on it. Okay, so before I cut off, the cusp angle is set to 60. We want this to be set to a lower value. And what cusp angle is basically when you hover over it, it'll give you a little tooltip about it. So when computing vertex normals, if normals of vertices around a single point are less than or equal to this angle in degrees, apart from each other, they will be averaged together. And because we've got a lot of geometry, because having a lower cusp angle works better for us. So anyway, we can start with the particles. So if you press tab, type in POP, we want to drop down a pop network, connect it, set the display render flag, and as we can see, it's got a few particles, but there's not a lot. And this will be a good time just to quickly talk about the takes. Now I've got different takes, but we're going to go into take one, go to pop source, and you can see everything's grayed out. But before I do that, I'll just give you a brief explanation of takes. So the take system creates a new take and allows you to promote parameters so they can be edited in that take. This is useful for finding what settings you like without impacting the work you've created so far, so you can easily swap between takes at the top right, which has the symbol of a clapperboard. So now I'm in take one, everything's grayed out. So if we go to birth, yeah. Now the main take, we've got the constant birth rate. We could change it there, but in take one, we can simply right click, include in take, and up the value. So as we can see that we've got more particles. Let's give it a bit more. Yeah. And say in take two, we can include in take and double that. And in take three, we can double that once again. Okay, so now we've got our different takes with the different amounts. So as you can see, main, take one, take two, take three, and each one has more particles. So let's go back to the object and let's select the pop network for this. Oh, we have to be in the main take for this one. Go back to render view and render it. Yeah, the particles are way too big. So let's close that. Go to take two. Ooh, actually, I need to go back to main. Go back to the scene view. And let's go back into the pop network, pop source. Ooh. So take three seems to have enough particles. So let's copy that. Go back to our main take and change it to that. So let's render that one out. So we've got the shape, we've got the particles, but they are way too big. So we need to go back and drop an attribute wrangle. Now we can actually leave this setting on rendering, connect that, go to attribute wrangle, set display render flag, and essentially we want to type at p scale equals 0.1. Forgot you have to put a semicolon at the end just so it knows when to start a new line, and we can see that particles are way too big now. So let's reduce this. There we go. So that seems quite enough, alright. I just forgot to mention under the render view we have a little camera here. If we enter it, we can add an image to history. So we've got that image selected. So if we change the particles to be a bit bigger, take a snapshot, we can see the difference in the particle size. So having a bit bigger gives them a bit more brightness. Let's change that to 3, set it to active render. That's rendered, take another snapshot. I'm just going to say having them set down to 2. Yep, that seems alright. So actually let's go a bit further. Yeah, actually let's drop that down to 1 again. Yeah, 1 is actually gives us the more detail because we can actually see the shape. So let's just do a snapshot of that, just so you can compare the differences. So if that was 2, set it to active render, let it render out. Do another snapshot, and then we can see, yeah. So it's definitely back to 1 for our active render. You may notice as well that these particles are just a standard colour. So if we stop the render, go back to scene view, drop a colour node. We have different colour types, so bounding box will give us this nice rainbow colour effect. Go back to render and render it out. Yeah, let's take another snapshot just to see what we've got so far. Now, using the colour node, you don't always have to use that. Let's just get rid of that. Go back to our attribute wrangle, put this effect, put the scale down a bit, and let's give each particle a random colour. So if we go down and type float r equals random, open bracket at pt num plus 1, close bracket, semicolon. Now let's just do another one. So float g equals random, open bracket at pt num plus 2, close bracket, semicolon, float b equals random, open bracket at pt num plus 3, close bracket, semicolon. So we basically got red, green and blue set to a random value, and to actually utilize this we do at capital C D, which stands for color density, equals set, open bracket, red, green, blue, close bracket, semicolon. If you click at that, you can see each particle now has its own random colour. So let's render that. Now each one's got a bit different colour. It's not that bright, so actually let's go back to the scene view, get a glow material from the material palette and apply that to it. Now if we go back to render view, do another render, it should be more brighter. So we can do another snapshot and compare. So that shows you that you can do a lot with Vex, and actually I'll describe what I've written into the attribute wrangle. So by using a float, we are defining a variable. So we've defined RGB, so red, green and blue, and we've equaled them to random. So red is random, green is random, blue is random, so each value is random. We use point number, so at pt num plus 1 plus 2 plus 3, just so that they don't clash. So each one it's the same expression, it's just a different version of it. So it could mean that red is 20, green is 15, blue is 24, but that's just for one particle. Each particle is going to have its own different colour. So now we've got that set up, go back to the scene view and just further progress. So 96. Go in the geometry node. You see there's a lot of colours there. Let's just render that one, see how it looks with more particles. Yeah, you can see the image. I'm going to take a snapshot and I'm actually going to go back into the pop network and just up the value a bit more. Wait for it to fully render out. Take another snapshot. So it's not adding too much more particles now, unless we, you know, up the amount. So as the timeline progresses, more particles will actually still be birthing because the life expectancy is set to 100. So they're always going to be there. If you lowered that value, some would spawn and then die out. And actually, this amount of particles further on the timeline, you can see it adds way more detail. So let's leave it as that. And we can get on to setting up a camera and actually rendering some work out, see how it looks at the end. Okay, so now the effect is all done. It's best to cache it out. So let's file cache, connect that, so that's display. Got the frame range, so we're just going to do save to disk. Yeah, so it's just going to cook this. I'll pause the video, come back when it's fully cached out, and then we get on to rendering it and setting up the camera. Okay, now it's saved the file to the cache. We can select load from disk, and then we'll actually just want to get rid of that. We don't want to delete it. Instead, let's highlight it and bypass it, just so it only is, it's not simulating anything, it's just playing it from the file cache. Okay, and in order for rendering to kind of give it a nice look, let's go out, and if we do hold control and left click up here where the camera is, it's going to place a camera in the current viewport. So you can see by the red lines we're currently viewing from the camera. If you ever wanted to move the camera, you can just go to this lock, press it down, hold left alt and move it around. So let's put it there, and we're still in the camera, so as soon as we click off that lock and do the same, hold down alt and move it, we're not in the camera anymore. So let's just zoom out, and in order to rotate the camera around, we can create a null, connect it to the camera and go to the rotate. So if we hold middle left click, you can see that the camera is moving. So a quick and easy way, instead of keyframing it, we can do $F, which means every frame rotate the camera. So it's picking the value from here, so 24, that will be 24, you just can't see it because it's $F. So that will go all the way around the geometry as it plays out. So if we go back into the camera, move to the beginning, you can see it moves around as the geometry goes. And that's sorted. Can I have a quick look in the render view, just to make sure we're fully happy. Yep. So let's stop the render, go over to here where it says OBJ, left click that and go to out. Now this is the render node, so we're going to select the camera, so it's already selected it. Valid frame range is currently set on to render current frame, we want to render the frame range. I reduced the total frame range to 240 because at 240 our simulation already finished at 140, so there'd be about 100 wasted frames. So once you're happy, you can just go back to scene view, go for it, just make sure you're fully happy with the final output. Yep. And we're okay with output pictures in EXR. Extra input. Rendering. You can change the render engine here. Allow motion blur, you can allow that. So it kind of gives that motion blur effect. So you just left click that. And once we're happy with that, we'll do render to disk. And that's it. I'll put up the video